noble gas configuration. In the first part, we learned about how to write the full electron configuration. As we can see that we needed the energy level chart, and as a reminder, we added the maximum capacity of electrons below each sublevel. Then we tracked these levels in order. But as we note, this process may take a longer time, especially for elements with a large atomic numbers. So, to make the process easier, we will write the electron configuration of the elements in terms of the noble gases by replacing the electron configuration of the inner levels with the symbol of the noble gas, which has a similar configuration. So, the electron configuration of the sodium becomes like this, while the electron configuration of the titanium will be like this. How is that? Let's learn together. As we know, noble gases are found in the 18th group of the periodic table. They are chemically stable elements. And this is the electron configuration of the noble gases. As we notice, the atoms of these elements are characterized by the fact that their outermost energy level is completely filled with electrons. Returning to the electron configuration of the sodium, which has an atomic number of 11, so we will choose the noble gas whose atomic number is closer and less than the atomic number of the sodium. It's neon, and its atomic number is 10. So, we're going to replace the configuration of the 10 electrons in the inner levels with the symbol of neon, followed by the configuration of the remaining electrons, which is 3s1. Notice that the symbol of the noble gas is written between brackets. While when returning to the electron configuration of the titanium element, which has an atomic number of 22, then the noble gas whose atomic number is closer and less than the atomic number of the titanium is argon. Its atomic number is 18. So, we will replace the configuration of the 18 electrons in the inner levels with the symbol of argon, followed by the configuration of the remaining electrons, which are 4s2, 3d2. But is it possible that each time we should write the full electron configuration first and then replace it with the noble gas configuration? So let's learn another way to shorten our work. As we mentioned a while ago, when choosing the symbol of the appropriate noble gas, its atomic number must be closer and less than the atomic number of the element. So, as we note in the periodic table, the noble gas which has an atomic number closer and less than the atomic number of the elements in the second period is helium gas. So, when writing the electron configuration of the elements in the second period, we will choose the helium gas symbol, followed by the 2s sublevel, and then we continue as we learn. While the noble gas, which has an atomic number closer and less than the atomic number of the elements in the third period, is neon. So, when writing the electron configuration of the elements in the third period, we will choose the neon symbol followed by the 3s sublevel, and then we continue as we learn. This method can be applied to the rest of the elements in the periodic table. And now, let's apply this to a set of examples. So, we will add the symbols of the noble gases next to the energy levels chart, where the helium gas symbol is next to the 2s sublevel, and the neon symbol is next to the 3s sublevel, argon is next to the 4s sublevel, and so on. For example, oxygen has an atomic number of 8. So the noble gas, which has an atomic number closer and less than the atomic number of it, is the helium gas. So first, we put the helium symbol, which has an atomic number of 2. 6 electrons are left out of the 8. So we will complete from the 2s sublevel, 4 electrons left, and we will add them to the next sublevel, which is 2p. Another example is the iron, and its atomic number is 26. So, as we note, the noble gas, which has an atomic number closer and less than the atomic number of it, is the argon. So first we put the symbol of argon, which has an atomic number of 18. 8 electrons were left out of the 26. So we'll complete from the 4s2, then 3d6. Phosphorus has an atomic number of 15. As we notice, the noble gas, which has an atomic number closer and less than the atomic number of it, is neon. So we put the neon symbol, which has an atomic number of 10. 5 electrons left. So we will complete from the sublevel 3s2, then 3p3. Another example is silver, and its atomic number is 47. The noble gas, which has an atomic number closer and less than the atomic number of it, is krypton. So we put its symbol first, and its atomic number is 36. We have 11 electrons left, so we will complete from the 5s2, then 4d9. Big thanks for watching. At the end, don't forget to like, share, and subscribe to receive my new videos.